you can break that into the square root of the first thing times the square root of the second thing. Okay, so you don't have to multiply them together right away. You can break them into factors of that number that we have. So for instance, if I had like the square root of 15, I'm able to think of that as the square root of 5 times the square root of 3. We wouldn't, because it doesn't help us any, but that's the idea. You can take something and break it into factors of that number and take those square roots, and you did not change any value. Okay. Same thing goes with division. So if I have the square root of a over b, I can break that into the square root of a divided by the square root of b. Okay, so you can break it up so that your square roots are separate there. We're going to be putting things into simplest radical form. And with simplest radical form, here are the details that you need to make sure of. There's a few things. So first, no radicands can have perfect square factors except one. So the number that comes under your radical, that's your radicand, okay? The number that comes under this symbol cannot have any perfect square factors, 4, 9, 16, all of those. You have to break it into the simplest form, reduce it as far as it can go, and you'll be in good shape. The other thing is none of your radicands can have fractions in them. So I cannot have a fraction under a radical symbol and say, I'm in simplest form, okay? It's the notes. It's right in your notes. And then the third thing, none of your radicands can appear in your denominator. So you cannot have a radical in the denominator. It's not simplest form if there's a radical on the bottom, right? Your denominator is that bottom number. You can't leave a radical there. Okay, so as long as you take care of those three things, you should be in what we call simplest radical form. Okay, so let's take a look at these. We're going to put all of these numbers into simplest radical form. So number 1 up above said you cannot have a perfect square factor. What is 50 divisible by? That's a perfect square. 25. So here's how I always do it. I break it into the left side is my perfect square, and the right side is my number that's not a perfect square. So I would break this into 25 times 2, because the square root of 25 is what? 5. So this is going to be 5 times the square root of 2. And that is your simplest radical form. Okay, so find a perfect square that goes into that number. Pull that out by breaking it into 2 factors instead of just the number. And then you'll get your simplest radical form from there. Square root of 2 we can't do anything with. There's no way to simplify that. Okay, so it's just 5 rad 2. Or you might say 5 root 2. There's a lot of ways to say it. 5 times the square root of 2. I like rad. I grew up in the 80s. 5 rad 2. Questions on that? Okay, now this one, there's a whole number out in front. Don't forget about that guy. This is just like when we factored before and we got our binomials. A lot of you on the test left out that number that comes out in front, right? Don't forget about him. He's got to come along for the party. So the square root of 12, what perfect square is 12 divisible by? 4. So this would be the square root of 4 times what? The square root of 3 is the exact same thing as the square root of 12. Okay? Don't forget about your 5 out in front. How can you simplify that?
2.
Right, the square root of 4 is 2. So now this is 5 times 2 times the square root of 3, which is 10 times the square root of 3. And now there's no perfect square that goes into 3. So that is your simplest radical form. Just coming back to you. Do you remember doing this? No? Okay, this one gets a little bit fancier because now we have a variable in there. Do you remember how square rooting works with variables? Can you square root x as something prettier than x, the square root of x? No, it's just the square root of x, right? If it was the square root of x squared, we would get x out of that. So when you square root a variable with an exponent, basically you're cutting the exponent in half. right? When you square root it. So if it was x to the 4th and I square rooted it, it would be x squared. If it was x to the 10th and I square rooted it, it would be x to the 5th. Odd numbers can't be square rooted, but we can do something with that. I'll show you that in a little bit. What perfect square is 700x divisible by? 100 would be the perfect square, right? So we're going to go 100 right here, but then we're left with a 7 and an x. Don't forget about the variable. The square root of 100 is what? 10. And then you have the square root of 7x. We can't do anything to that, so that's our final answer. 10 times the square root of 7x. Questions on that? Okay, I'm going to do this one with you, and then I'm going to see if you can figure out the next one on your own. Number 4 here. We said you cannot have radicals in the denominator. So essentially right now, you could think of this as the square root of 2 divided by the square root of 3. Anyone remember how you get that radical out of the denominator? Multiply by what? Not the reciprocal. You multiply by the denominator over itself, right? Because we don't want to multiply by the square root of 3, because that's going to change our value. We don't want to change the value of this number. We want to simplify it. So if I multiply by 1, it does not change my overall value, right? The way we're going to multiply by 1, though, is by multiplying by the square root of 3 over the square root of 3. Does that make sense? So we're not changing the value if we're multiplying by 1. Something times 1 is itself in a different format. So when we do this, what do you get on top? You multiply across here. What is this? The square root of 6. Okay, if you multiply here, what's the square root of 3 times the square root of 3? 3. It's the square root of 9. Which is 3, right? So this just simplifies to the square root of 6 over 3. Now here's the deal. A lot of people right here want to try to make this the square root of 2. Why is this not equal to the square root of 2?
Because it's the square root of 6 divided by 3, not the square root of 2.
Right. You can't divide a square root and a non-square root. A radical and a non-radical, you can't divide them. So this has to be your final answer. You just leave it like that. We got the radical out of the denominator. So we're good to go. There's no perfect squares that we can divide out of that, so that's your answer. Okay? All right. Using that same idea, why don't you try number 5? And now here's the deal, guys. There's 2 ways you can do number 5. You can do it exactly how I just did it over here. You're going to get slightly bigger numbers. Or you could start just with this and simplify the square root of 12 a little bit first, and then do what I did over here, and you'll have smaller numbers to work with. That's up to you. Give it a go. See if you can figure out how to make that work, and then we'll do it together. Yeah. Number 3. This one's probably the toughest one we've done so far. Has the most work to it. How many of you have an answer? Just a couple. Okay, out of curiosity, even if you're not done yet, how many of you are doing times the square root of 12 over the square root of 12? And how many of you are breaking the square root of 12 into the square root of 4 and the square root of 3 first? Okay, looks like we have more of the square root of 12. So I'm going to do it that way since that's what most of you seem to have done. What'd you get for an answer? Square root of 60. Okay, so yes, the square root of 60 over 12, but there's a perfect square that you can pull out of the square root of 60. So you actually have to keep going from that. What'd you get? Okay, the 2 and the 12 can be reduced. But yes, then you have the right answer there. So here we go. If you multiply by the square root of 12 over the square root of 12, on top, we have the square root of 60. On bottom, the square root of 12 times the square root of 12 is 12, okay? When you multiply a square root by itself, it's the number underneath. It's your radicand. So the square root of 12 times the square root of 12 is the square root of 144. Square root of 144 is 12. Johnny, you just got coffee. You don't get to sleep right now. Wake up. So it looks like this, okay? But we can break this square root of 60 into what perfect square? And 4, right? The square root of 60 would be the square root of 4 times the square root of 15. So this is 2 rad 15 on top. And then you have 12 on bottom. Now, you have 2 whole numbers there. You can reduce those. 2 over 12 is going to be 1 over 6. So we get the square root of 15 over 6. That makes sense? Anybody get that?
Wait, so what did you
Job, Chris. What?
So you just crossed out the 2.
So we're just reducing. Think of it as the fraction 2/12, right? Is the same as the fraction 1/6. We're just dividing both of those by 2. All right, number 6. This one, oftentimes people try to do more work here than they need to. What do you see?
3 over 4.
It's the square root of 3 over the square root of 4. What is the square root of 4?
2.
2. So do you need to multiply by the square root of 4 over the square root of 4? No. If this breaks down to a perfect square, just use that. Square root of 3 over 2, and that is your final answer. Okay, so look for perfect squares. Sometimes they show up when you're not really expecting them, and then you end up doing a whole lot more work than you need to. No need to do the extra work. Okay, number 7. What would you do here? What are you going to multiply by? How do you get a radical out of the denominator?
Square root of 2 over square root of 2.
Yes, rad 2 over rad 2. So on top, you get 6 rad 2. What do you get on bottom? The square root of 2 times the square root of 2 is 2, right? The square root of 4, which is 2. And then just simplify that. 6 over 2 is 3 over 1. So 3 rad 2 will be your answer. Questions on that? Yeah.
It's like I see what you did, but
So whenever there's a radical, when there's a fraction, okay, and there's a radical in the denominator, you're pretty much always going to multiply by that radical over itself, or you always can, right? So in the last one, we didn't because we had the square root of 4, which is already 2. So we didn't do that. But if I had done that, I still would have gotten to the same answer. So if in doubt, if there's a fraction, multiply by the denominator over itself, right? Because this is essentially the number 1. And if you multiply by 1, it doesn't change the value of what we're talking about. And then from there, it's just multiply across. So multiply 6 times rad 2 and multiply rad 2 by rad 2. And I get 6 rad 2 over, technically this is rad 4, but we simplify that to 2. And then you can reduce 6 over 2 is 3 over 1. Okay? Okay, this one. Again, a lot of people do extra work on this one. That doesn't actually have to be done. What is the square root of 6 divided by the square root of 2?
Square root of 3.
The square root of 3. If you can divide it first, okay? We can divide those because they're both radicals. We're allowed to divide them. This is just the square root of 3. Okay? All right, number 9. What are you going to do there? multiply by the square root of 3 over the square root of 3, right? Multiply by 1. So it doesn't change our value. So up top, if I multiply these, I can only multiply the radicals together and the non-radicals together. So the 3 doesn't get multiplied by anything, but square root of 7 and square root of 3 becomes the square root of 21. Okay, and that's over, what does this become? Square root of 3 times the square root of 3. Not 6.
Oh, 9.
It's the square root of 9, which is always that radicand, 3. So square root of 3 times square root of 3 is the square root of 9, but the square root of 9 is just 3. So right now we have 3 rad 21 over 3. What do you do with that?
You divide.
Divide. 3 divided by 3 is 1. So it's just the square root of 21. There's no perfect square that comes out of 21. So you just leave it like that. How we doing? Is it coming back? It's been a little while, huh? Okay. Now they start to look a little bit fancier because now we have these operations in between. So with a plus here, you cannot divide just the 4 by 2. You have to divide everything by 2 because it's an expression, right? There's an operation happening there. So what we do first is we break this square root of 20 down. What perfect square is 20 divisible by? 4. So this is the square root of 4 times the square root of 5, which is really 2 times the square root of 5. Okay, so right now our problem is 4 plus 2 rad 5 over 2. Okay. Now we can do some dividing. It has to be that everything is divisible by 2 if we're going to divide by 2. So these are divisible by 2, and these are divisible by 2. So that's what we're going to do. 4 divided by 2 is 2. 2 divided by 2 is 1. So it's just 2 plus 1 rad 5, which you can just call rad 5. So that denominator of 2 just goes away. Okay, so just make sure when there's an operation, when there's a plus or a minus in between there, and you're working with an expression instead of just a term, that you simplify everything. Okay, this one. What does the square root of 18 break down to? What perfect square? 9 and 2. So square root of 9 and the square root of 2. So we have 6 minus, this becomes 3 rad 2, right? Square root of 9 is 3. And then rad 2 over 6. Okay, now from here, you kind of have, well, no, we're going to say you don't have two options. What do you do with that? Is everything divisible by 6 nicely?
No.
No, but it is simplifiable, right? So if you look at this part of it, 6 over 6 is 1, okay? This part of it is 1 over 2. So we're going to say 1, keep our symbol, minus, and then this is going to be the square root of 2 over 2, and that's how we're going to leave our final answer for that one. So reduce, but you can still have a fraction as long as there's no radical in that denominator.
Where did you put the 3 from?
Right here, square root of 9 is 3.
Okay. So you don't put the 2 here?
The rad 2 is right here. Okay. All right, number 12. We're going to break that square root of 12 into the square root of 4 times the square root of 3. So it's a negative 6 plus, that would be 2 rad 3, right? We're just taking the square root of 4 over 4. Everything here is divisible by what? 2. So we're going to simplify by dividing everything by 2. So this is going to be a negative 3 plus, that's just a 1 now, rad 3 over 2. And that would be your answer. Now, technically, you could write this as negative 3 halves plus the square root of 3 over 2. That would be the same thing. It's not wrong. I feel like this one's a little bit simpler, so I would probably write it that way, but that's up to you if you want to do that or not. Questions on that? You done? take it. Thank you, sir. Okay, sorry for the X's here. It's just supposed to be a dot, but same idea, times. 13 is the square root of 2 times the square root of 14. What do you do? What do you think? Is there a perfect square you can take out of either of those? No. What if you multiply them together? The square root of 28. Now is there a perfect square?
Yeah.
Now there is. So now we're going to break that into the perfect square and the non-perfect square. What are those numbers going to be? 7 and 4. So I always put the 4 first because that's the perfect square. So 2 rad 7 is as simple as you can get that. Okay. What if you square the whole thing, like number 14 here? What do you have to do? Do you know? What? Oh, PEMDAS. I mean, it's just the one step of PEMDAS. You do the exponent, right, Chris?
9 times 5.
Right. So you need to square the 3. And you need to square the square root of 5. What is the square root of 5 squared? 5, right? It's just 5. Because you're essentially saying these two parts cancel each other out. The square root and the squaring just are inverse operations. They cancel. So you have 3 squared is 9 times 5. If you want to think of this, the square root of 5 squared as the square root of 25, you could, right? Which is 5. That's another way to look at it. But it would be 9 times 5 or 45. So your radicals go away completely with that. Questions on that? What? They're just different. New things. Okay, this one. The square root of 2 times 7 times the square root of 8. What can you actually multiply there? Only the radicals, right? 7 is going to be by itself, but the square root of 2 times the square root of 8 is the square root of what? Square root of 2 times square root of 8? 16. So you get the square root of 16. What is the square root of 16? 4. So we're saying 7 times 4, or 28. So again, all your radicals go away, and you just get 28 for that. Questions on that? Okay, last 3. Here we go. I feel like this is maybe the easiest one on here. What does that become? 10a. Take the square root of 100, that's 10. The square root of a squared, square rooting and squaring cancels it out. Or if you square root, you divide your exponent in half. So it's a to the first. So 10a would be your answer for that one. Okay. 17. Okay, so now this one, you have a couple options for how you want to set this up. Do you remember the properties of exponents? X squared over x. What do you do with that? What do you do with the exponents?
Cubed. X cubed.
Not cubed.
No.
Well, this is currently x cubed over x to the first. But when you divide with exponents, what do you do with these numbers? You subtract them, right? So this becomes just an x squared on top. So you can think of this as the square root of 2x squared over the square root of 3. And that just helps simplify our exponents a little bit and our variables. Up top then, we would get the square root of x squared is what? What is the square root of x squared?
X.
It's just x. You take that exponent and you divide it in half, right? So we have an x. We have a square root of 2 still, and that's over the square root of 3. What do we have to do still? How do you get that radical out of the denominator?
square root of 3 over square root of 3.
That's the one. Yeah, we're going to multiply by rad 3 over rad 3. So we get on top, we get the square root of 6, and we still have that x out in front. On bottom, what's the square root of 3 times the square root of 3? It's not the square root of 3. 3, right? It's the square root of 9, which is 3. So this is as simple as it gets. Okay. Last one. Here we go. Can you tell me what 2 to the 4th power is? 2 times 2 times 2 times 2?
I think it's 64.
It's not 64.
32.
No. 2 times 2 is 4. Times 2 is 8. Times 2 is
32.
16.
16. Oh,
16. So this would be the square root of 16 over the square root of 50. You have a couple options here. You have a lot of options here, actually, how you do this one. Tell me what you see. What would you do?
16.
Okay, so you could simplify this right now to 4. And then what would you do with the 50?
I'd split it into 25 and 2.
25 and 2. So that's 5 rad 2. So you get 4 over 5 rad 2. How do you get that radical out of the denominator? Yeah, you're going to multiply by rad 2 over rad 2. So if you do that, you have a 4 rad 2 on top. On bottom, you have 5 times rad 4, which is 5 times 2, right? So that's going to be 4 rad 2 over 10, which can be reduced. 4 and 10 will reduce to 2. Oops, 2 rad 2 over 5. Okay, which is your final answer. Did anyone see it a different way? Because there's an easier way, but it's not probably the way that you see, because when they give you a perfect square, it's so hard to not square root that right away. Anyone see a different way you could go from right here? Square root of 16 over the square root of 50. If you reduce that fraction first, if you make this, they're both divisible by 2, so the square root of 8 over the square root of 25, that gets your radical out of the denominator right away, right? And then this would be the square root of 4 times the square root of 2, so that's 2 rad 2 over 5. Notice, same answer, much less steps. So there's often multiple ways to get there with these. Take the one that you see, and hopefully you pick the easiest. Any questions on that?